Okay, so finding sides and angle lengths. This should probably be reviewed for you guys, but if not, that's okay. We'll just work through it. So finding side lengths. So SOHCAHTOA, you should have talked about this before. But SOHCAHTOA, that's just sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We were doing this last time. So to find a side length, we first need to determine, are we going to use sine, cosine, or tangent? And we're not going to use the reciprocal functions because we don't have a button in the calculator for them. That is really the reason why we're not using them, okay? So if we look at this, there's my opposite side, and that's the hypotenuse. So sine uses opposite and hypotenuse. So this is going to be sine of that angle, so sine of 64 equals the opposite side, which is x, over the hypotenuse, which is 25. Then we can put that over 1, and we're just going to cross multiply this. Okay, and I just put it over 1 because it helps you see a little bit easier what we're doing at this point, okay? So that's going to be 25 times the sine of 64 equals x. Put that into your calculator, but it must be in degree mode. If you are not in degree mode, you will get this wrong. Mode is right next to the second button. So if you just click mode, make sure that degree is highlighted, and you should get 22.5. Okay, if you don't get 22.5, it's probably because of your mode. And if not, then you really struggle putting that into the calculator, and you should come talk to me. And we'll figure it out, okay? Let's do another one. So this one, again, let's label, that's the opposite side. There's my adjacent side. So opposite and adjacent, that's tangent. So tangent of 47 equals the opposite side, which is x, over the adjacent, which is 12. Put that over 1, cross multiply, so you get 12 times the tangent of 47 equals x. Put it in your calculator, and you get 12.9. Okay, I want you guys to do example C. You should get 32.3. Make sure you can get 32.3. Okay, let's look at this one. So again, let's label opposite and adjacent. So that's tangent again. So tangent of 35 equals 9 over x. Put it over 1, cross multiply, and you get x times the tangent of 35 equals 9. We have to get x by itself. So x, we just have to divide by the tangent of 35. So you get x equals 9 divided by the tangent of 35, which is 12.9. Okay, let's do this one. Opposite, hypotenuse, which is sine. So sine of 63 is 27 over x. Over 1, cross multiply, so x times the sine of 63 equals 27. Divide by the sine of 63, and you get 30.3. Okay, you do example F, you should get 20.8. Cool? Okay, let's look at angles. So anytime you find an angle, you have to do the inverse. So if we look at this, sine of theta equals x. So say you have sine of theta equals some number. Well, theta is just a variable, and we need to solve for that. So theta equals sine inverse of x. Same thing with cosine. Theta equals cosine inverse of x. Same thing with tangent. Theta equals tangent inverse of x. So anytime you find an angle, you have to do the inverse. Okay? Anytime you find an angle, you have to do the inverse. Okay? So in the calculator, inverse is just second tangent or second cosine or second sine, whatever it may be. So if we look at this, there's my opposite side, there's my adjacent side. So this is going to be tangent. Tangent of theta equals 8 over 14. But I need to solve for theta. So that means theta equals tangent inverse of 8 over 14, which is 29.7. Okay, let's look at this one. So there's my opposite side. Hypotenuse, adjacent. This time I'm only given hypotenuse and adjacent. So that's going to be cosine of theta equals 38 over 40, which means theta equals cosine inverse of 38 over 40, which is 18.2. Okay, you can do examples I and J. You should get 50.6 for I and 74 for J. Okay? All right, angle of elevation. This isn't too bad. As long as you draw a picture, you'll be fine. But so the angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. If the top of the lighthouse is 161 feet above sea level, how far is the boat from the lighthouse? Well, let's draw our angle. So our boat is right here. It's a great boat. This is the lighthouse right here. There's a light right there that shines. Anyways, okay, so that angle is 5 degrees right there. That's the angle of elevation. The lighthouse is 161 feet. We need to find how far the boat is from the lighthouse, so we need to find that measure right there. So that's going to be tangent, so tangent of 5 equals 161 over x, which means x, tangent of 5 equals 161. Divide by the tangent of 5, and you get 1,840.2 feet. So that's how far the boat is from the lighthouse. Okay, you can do example L. You should get 23 feet. Let's do this one. So a 10-foot ramp is used to unload furniture from a truck. If the back of the truck sits 3 feet above the ground, find the measure of the angle from the ramp Find the measure of the angle that the ramp makes with the ground. Sorry, I mixed up words really bad. So here's our truck. Yep, that's the truck. And that's me driving the truck. Smiling. Okay, wow. Sorry. So anyways, and then the ramp is 10 feet long. Sorry, I got distracted. The ramp is 10 feet long, and it is 3 feet above the ground. So this is our ramp. If we could go back to my cute picture, we'd see this is the ramp coming off of the truck that I drew earlier. Okay, and we need to figure out the angle that the ramp is making with the ground. So we need to figure out that angle right there. Okay. So from that angle, that's sine, because we have opposite and hypotenuse. So sine of theta equals 3 over 10, which means theta equals sine inverse of 3 over 10, which is 17.5. So that angle is 17.5. Okay? Now, angle of depression. This has always been kind of, my brain has had trouble comprehending this a little bit, so hopefully I can explain this well. But a fire is spotted at the top of a 125-foot tower. If the angle of depression to the fire is 19 degrees, how far is the fire from the base of the tower? So angle of depression, that's as if it's outside of our triangle, okay? So the angle of depression is this right here. That's the angle of depression. This is not the angle of depression. No, 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 no. This is the angle of depression, okay? So if the angle of depression, the fire is spotted from the top of a 125-foot tower. So that's 125 feet. Now the angle of depression is 19. So that's 19 right there. And we want to know how far the fire is from the base of the tower. So we want to know that distance right there. Now there are 2 ways we can go about this. I think the easiest way that I figured out how to go about this is to just figure out what this angle is right there. Okay? So I know that this right here is a right angle. Now, a right angle, that adds up to 90 degrees, right? So to find that angle right there, I'm just going to take 90, and I'm going to subtract 19. I'm going to get 71 degrees right there. Okay, now I can just use what I've been using to find x. So that's going to be tangent of 71 equals x over 125. Which means x equals 125 tangent of 71. So that is 363 feet. Okay, there's other ways to solve this, and if you figured out those other ways, you are a rock star, and that's completely fine. As long as you're getting 363 feet and you can justify your answer, that's awesome. Okay? I want you to do example O. You should get 16,738.5 feet. Okay? Let's do this last one. So Max is sitting in the stands at a baseball stadium. He catches a foul ball and decides to throw it back to a player standing on first base. If the horizontal distance from Max to the player is 61 feet, so that right there is 61 feet. and the ball travels 76 feet. Because remember, Max is like up here. Hi, Max. Max. Right there, throwing, because these are stands, right? Obviously, that's what they look like. But think of like a baseball field, like you're above where they're actually playing, right? So when he throws the ball, he's throwing it downhill, or down, not downhill, but just like down, you know, and he's throwing it 76 feet. Anyways, we want to know what the angle of depression from Max to the player is. So we want to know what that angle right there is. Well, let's start, because we don't really have a lot of information for that. Let's start by finding that angle right there. Okay, let's use the triangle that we have. Let's find that angle. So we can do sine of x equals 61 over 76, which means x equals sine inverse of 61 over 76, which means x equals 53.4. But that's not what we're trying to find. We weren't trying to find x, we're trying to find theta. So we just need to do 90 minus 53.4, and you get 36.6 degrees. So the angle of depression there is 36.6 degrees. Cool? Thanks, friends. Remember to take the quiz. Okay, bye.